Hello and welcome. I'm Bill Wake. We're here working on a basic interpreter written in Swift. We've done the bulk of it, probably 95% plus of the language, and we're working on the environment, the runtime. I guess you could say the REPL, the read eval print loop, or the console piece of it. And we've been focused lately in the last couple days on a display of all the variables. So you can do a sort of breakpoint with a stop statement and come in and examine all the variables. And we've got the basic variables, the numbers and strings, showing quite well, or at least good enough. And we've got something to show when you show an array, you can click an eye icon and it'll bring up the list of all the values of the array. We'd like to show that with the indexes, and that's the part we're going to focus on today. I think I've been resisting it. I don't know. All right, so just kind of a quick refresh. Since I messed up the recording yesterday, you may not have even seen any of this. But when you do multidimensional array access, your computer's just got a big pile of memory in order indexed, and we're implementing in that same way. We're going to have a simple one-dimensional array to represent your data, and then we'll do the multiplies and adds to get from the index, from the multiple indexes, we'll combine them and get a single number that's the position in the linear array. And then in this case, we're going backwards. We've got the number on the left there, I. So A1, 2, 3, well, the first index can go from 0 to 1, the second from 0 to 2, the third from 0 to 3, okay? And so you have 2, 3, and 4 values in each of those columns, and they're independent, so you multiply, and you get 24 cells numbered 0 to 23. And so laying out linearly, that's how we'll do it. And what you see is the indexes, we're doing it in a way, and I always forget if it's a row major or column major, but there definitely are two terms for that. Whether you're varying the first index fastest or the last index fastest, and we're doing the one where you vary the last index fastest. So you can see 0, 1, 2, 3, 0, 1, and then 2, 3, and 0, 1, 2, 3, 0, 1. It repeats like that. The second index in the middle there is slower. It's zeros, ones, twos, and then goes back over zeros, ones, twos. For each one of those numbers, 0, it goes 0, 1, 2, 3 on the index 3. Then the index 1 is the slowest of all. It's, all the zeros, then all the ones, and that's all there is. So it's kind of, I think of it like an odometer on a car. It's just that instead of 10 digits on each wheel, or electronically inside nowadays, there's a varying number depending on the dimension of the array. But if we get to 0, 1, 2, 3, and then we go to the next one, it's modulo. We got to go back to 0. And so to compute the index, if you just take I mod 4, it runs 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, and so on. All right, to get that second index, well, you got to account for the fact that there's going to be 4 copies of each one because the third index has 4 entries. So 0, 1, slots 0, 1, 2, and 3 are all index 0. So we got to divide by 4. And then once we divide by 4, we'll take mod 3, the number of indexes in column 2, and that'll get us number 0, 1, or 2. All right, and then for the third, for index 1, the outermost slowest going, we got to divide by 4 times 3. Okay, so the product of index 2 and index 3, and we divide by 12, and then mod 2, it's going to come out that way anyway, but mod 2 because there are 2 values possible for index 1. So sometimes it's nice to do this on the corners. So 0 divided by 12 is 0, mod 2 is 0. And same thing, 11 divided by 12 is 0, mod 2 is 0. And then you get to 12, and now it's 12 divided by 12 is 1, mod 2 is 1. So you can see entry 12 is a 1. And same thing for 23. It doesn't quite meet 2, so 23 divided by 12, throw away the remainder, is 1, mod 2 is 1. All right. And I was hoping, I don't know. The other way you can do this is more like the odometer style. I could start with 0, 0, and I could increment 0, the index 3, 0, 1, 2, 3. And if I increment it to 4, I should say, oh, wait, that's too big. I need to subtract 4 because the size of the index, and then add 1 to the next column. Okay. And if that overflows, I have to subtract 3 and add 1 to the next column, and so on. That'd be one way. Another way would be these things are, to list all the indexes, I'm taking the cross products of 3 ranges, 0 to 1, 0 to 2, 0 to 3. And if I did those in sort of, low to high order, the cross product would be those 24 numbers, and that would be that. I didn't see any of that out of the box, so I think we're just going to have to go through and implement this little approach. Okay, and I don't know. Maybe we just had other stuff to do yesterday, but I kind of was putting it off too because it's just annoying. I want somebody else to do all that work for me, But okay, I didn't see it free, so we will do it. And it's actually probably I should just go through and do it, low level TDD and just go for it that way and build up a little incremental one. I don't know. I don't often have to do that so much at this point, depending on the stuff we're doing. Most of these grammar things we've been doing for a while, it's just you match the stuff and, plug it in and it happens. You don't have to really think too hard about formulas or any of that stuff. But that's okay. That's the way they pass. All right, so variable display for arrays, variable display in scroll view. Let's put that one first. I'm going to take the easy one. Hey, Rick, nice to see you here. All right, let's see. So, and I saw something else. Let's see if I can. What was it? Oh, is integer. We have as number somewhere here. As number, I think. Maybe not. Oh, okay. Okay. What I observed, let's see, it would be in value. Where is value? Oh, I'm in value. Basic array. This bit. It's kind of a puzzle to me. So this is basically given the list of indexes. So like our 3 columns, if I took 1, 2, 3, that's a valid index. I should be able to feed that in. It'll tell me the linear number. All right. And it does it maps things, and then it checks errors, and then it does the work, which is like accumulating the indexes and, multiplying by dimension and so on. We're doing the inverse operation is what we want to do. So, but I saw this int. It's like, oh, could value just be give me an integer? And then the other question in my head was like, do I really want to do values or do I want to do ints? And I don't know. Like here we said, oh, we can do get index of int. But yeah, I don't know. So this is useful for what we got from the basic side. Values are what come in from evaluating expressions. And but internally, we have places where we have lists of integers. I mean, even in here, right, we map it to integers first off. All right. And like, should I push that to the caller? I don't know. Who calls this? I think it's all internal. Right. Okay. So let me at least make this file private. Okay. Just make sure that builds. I don't know. I don't sweat private so much in Swift. I used to be much more strict about it, period, even in Java or C++ or whatever. And I got less concerned. I don't know. All right, let's see. Here's tests. Okay. Um, why are you showing me errors? Basic array tests. Well, that seems unfair. We'll just put a test stub. True, true. Okay. Just to make sure everything's okay. And we'll just commit refactor. Private to index 4. Wow. And stub test in basic array tests. Let's see if I can turn this into English. Added. Okay, and this is number 37. And we're focused on variable display for arrays. Excuse me. All right, variable display in scroll view. Okay, so I'll just create an array. Dim A235. Okay, so there's 3 times 4 times 6 entries. That's a lot. No, I didn't actually commit it. And let's just put something in A sub 1, 2, 3 equals 42. All right, now we got variables. The only variable is A. It's an array 235. That's good. Type is number. And we have this, but I can't scroll it. Okay. I'm surprised it would even show like this, but okay. So let's do that first. Scroll view. We were back at 129. I saw Dim Sum Thinking is another Apple person writes on that, and he was just complaining the other day when you reformat it, it doesn't put you back where you started. Okay, let's run this. Now we're going to focus in here. This stuff we definitely can do better. All right, 10 dim A235 A sub 1, 2, 3 equals 42. And we'll look at A. Okay. Interesting. There's the 42, but notice, like, how do I know that's in the right position? Well, I don't. Okay. We'd like to say A sub 0, 0 equals 0. A sub 0, 0, 0 equals 0. A sub 0, 0, 1 equals 0. You know. I'd also like this to be kind of size limited. I don't know. I'd like a little more room on the sides. Let's see. That we can do. I know we did some frame stuff earlier. Maybe we can kind of match that. I guess here. And let's make it a bit smaller. Okay. And then I'm going to put some padding. Oh yeah, much better. Much better. I know we did a font up here somewhere too. Well, it's probably down here. Right. I don't mind showing this stuff, the contents in a fixed font, because maybe you wanted to count string characters or whatever, but the other ones I would rather be just like a sans serif. No completions. Let's see what round it is. I don't know. We can make it a little smaller maybe. And style, no. Bold. Okay. I don't know, just tweaking. Okay, that's tolerable. Yeah, that's definitely improved. Okay. Variable display and scroll view. That I would say is done. Okay. So the real thing, let's see where we're iterating through. You know, another way they do it is list. Let's try that. I don't know if it'll look better or not. Usually lists, I think they get either lines between between the sections, or alternate colors or something. That's a little less beautiful, isn't it? I don't know what the problem is. Okay, well, we'll stick with this then for now. Oh, I took a note to myself. What did I do with it? List for each array, id self. Let's try that. I tried this with something else yesterday, and it wasn't self, though. Let's see if this... I'm not sure if it's dot self or just self. Basic array. Okay. Oh, got errors. Value conform to hashable. That doesn't seem unreasonable. Can I convert value of value to expected type int? Why would I expect int? See what the type of X is. Well, that's not good. All right, let's make value hashable first. And I may have to do some, yeah, okay. Let's get out of here. We'll get there. I don't know. I don't like that complaint because it sort of makes it sound like something's not good. But all right, let's go over. So really, I want this stuff going on. Excuse me. So I think the real thing is I've got an index here, $0, and I want to go from the index to a pair of values. Okay. And so I think what I need is something that a function that's kind of the opposite of this, and you give it an integer index and it gives you the indexes for it. Okay, so this is index, the singular. I think I want an index for indexes for plural. Okay. So rather than spit that out in English, let's try it in code. Index is 4. And then the case I wanted to start with, well, let's start with a couple of cases. Last index. Let's see if I can make that make sense. Okay, so let index equal. Well, let's start with this. Let's just start with 0. Index equals 0, and we need a basic array. Array equals basic array, and it's got to have the dimensions. Oh, we got two of these. There's an easy one. Yeah, this one. It needs dimensions and a type. It'll create an empty one for us. Okay, and dimensions. Well, let's take our example. We did 2, 3, 5, right? No, 1, 2, 3. Okay. If I ask for index 0, and then I say let result equal array.indexes for index. Okay. And then I want to assert equal. My result should be 0, 0, 0. Okay. Array has no member indexes 4 yet. That's right. Index equals 0. Okay. Let's make this compile. Basic array. Well, we need index is 4, and it needs an index of int, and it produces an array of int. We'll return this for now, and our test should fail. Okay, and I'm going to take the easy way out. I'm just going to return 0, 0, 0. because I want to refactor this test already. So let's define a helper function. Function check indexes. And we're going to give it the index 0 and the expected, oh, well, sorry, this is array event. Okay, and this is an int. And I don't think I'll keep the wording on those. Okay, and it's basically going to do this. All right, but this index comes in, and this is expected. All right, and this becomes check indexes, index 0, expected 0, 0, 0. Okay, and if I check indexes, index, well, I want to do this one, 3, I get 0, 0, 3. So it's somewhat of a parameterized test, I guess you could say. I've got a framework for it. I really need to develop that. Maybe that's my next project. All right. So 0 should be 0, 0, 0. 3 should be 0, 0, 3. Okay. That will fail. The second one's not right. Okay. And 0, 0, 0 because it's hard coded. So let's change it. And I'm going to take the teeny tiny steps today just because I've been so resistant to this thing. What if I return index? Okay. But we can prove that's no good if we go on to 4. We expect this to be 1, 0. Okay. Yeah. That's, well, I'm not sure how to do that. Okay. Well, we definitely want to return index mod 4. Okay, but this one, let's put some formula in. Let's just do the index divided by 4 bit. Okay. Okay. So we can see the mods working. This one, I don't know, is this helpful? In a way, I'd be better off if I just asserted dot last and got the 0, the 3, the 0. Maybe I don't need to break out. Maybe I'm just doing increasing numbers. Okay. Then the next one that's a problem, right? 0, 1. Well, 0, 2, 8 switches the middle index to 2. Is that going to work? Well, I think it will. Okay, and then, all right, So we've got some level of generalization here, but the number 4 is coming from our dimensions. It's really well, it's dimensions.last plus 1. Okay, so mod 4 is 0, 1, 2, 3, because that's the values for this thing. So if we use the last index, and I'm just trying to generalize a little bit. So this is it called dimensions? Okay, dimensions dot last, and we kind of know it exists, plus 1. And we did store those directly, right? We didn't increment. Yeah, there's a little bit of funniness. When you declare it, you declare like a sub 1, 2, 3. It actually ends up being 2, 3, 4 when it gets down to the array. We don't take that into account. The caller takes that into account. Okay, but this should be okay. Okay, and so this well, I think Swift can do this much for me. Okay, I don't need these parens now. And this 4 is the same number, it's last dimension. Okay. Okay. Now, we hard-coded a list of 3 things. There's nothing that makes this have 3 dimensions. It's an arbitrary number. So we really need to work from the last dimension across. Okay. Let's put another case in. Hello, nice to see you. So we're working on a basic interpreter written in Swift, and we've got most of the language done. We're working on a debug display that shows arrays, and we can show their contents, the values in the array, but we don't really show the indexes. So if it's a multidimensional array, we'd like to see a sub 000 equals 42, a sub 001 equals 27, and so on. So we're doing the part where you have a linear index into the array, but we need the multidimensional values for that. So kind of a little math problem. Okay. So I'm going to add another case. Okay. The case I want to add, well, unfortunately, yeah, this is the case I want to add. 12 is the first one that changes index 1. Okay, so if you expect 12, we expect 1, 0, 0. All right, this will fail. Okay, 0, 3, 0. But our array is only supposed to go 0, 1, or 2 on that middle index, so this is not a good answer. All right. So we have the answer here, sort of. The formula we worked out. I need to divide by, for the second index, I need to divide by 4 and take it mod 3. That's certainly true. So let's well, let's change this to dimension 3. Rename. I'm just kind of working it up from very minimal cases. Let dimension 2 equal dimensions sub 1 plus 1. I don't know if I have to. Yeah. Okay. Oh no. Was saying wasn't used. Okay. So if I take index divided by dimension 3 and then mod dimension 2. Well, still didn't like it. Dimension 2. Okay. I think my last digits will be right, but whoops. Oh, man. Okay. My last digits will be right. This is hard-coded to be a 0, so it can't be right. Okay. And we know from formula, this one is supposed to be this, divided by the product. Okay. So this should be index divided by the product, dimension 2 times dimension 3. And modulo dimension 1. And let's make this consistent. Okay. All right. So with this, I think we can expect everything to be right. Let's take 13 and then 23. Okay. Cool. And this should be 101. And this should be 1, 2, 3. All right. So what we've accomplished in a pretty minimal, ugly way, if you give us a multidimensional array with 3 dimensions, we will pull them out and calculate this. Okay. Now, what I want to do is move that into a loop. And I don't, let's see. The funny thing is, it's easiest to calculate this first. I mean, that one is always the index mod whatever. So I kind of, yeah, because what happens is you have to accumulate dimension 3 and all that as well. So see the multiplier here is 2 times 3, dimension 2 times dimension 3. Here it's only dimension 3, and here I guess I could make it more similar, right? I could say index divided by 1. Okay, so I'm driving duplication in to it drives in duplication, but it's making them more similar. So the first term we calculate is by 1, divide by 1. Then we multiply the dimension to get the second term, and then we multiply by its dimension to get the third term. So this product is 1 times dim2 times dim3. Okay. And I don't know if I could make that explicit too. It'll fall out in the end. I'm just trying to make the conceptual similarity more visible. Okay, so one thing, one thing I want to do, the thing is, it's easier to go from this one towards this one because you need all these dimensions, right? So I want to build the list backwards. All right, so let's do this. Let result reversed equal nothing. I guess that's got to be var, and its type is array of int. Okay, so I'm going to try and switch this to an accumulating model, and then it'll work with arbitrary numbers of dimensions. Okay. Let's see. So I want to go, well, in the end, I want to return result reversed dot reversed. Okay, so I'm generating them backwards, and I'm going to reverse them so they come out forwards at the end. Okay, now I'm going to work from, I'm going to make this, I'm going to rearrange. Okay, these are independent calculations, so there's no reason they can't come in any order. All right. This should all work, even if it is complaining about stuff I'm not using. Okay. Now let's do result reversed dot append, and let's append this. That's one too many. Okay. And then once we have dimension 2, we can append that. Index divided by that, mod that. And then finally, we can do result.append this thing, that. Okay, so let's break this up a little bit. Okay, this should still work. Okay. So I'm just appending the pieces in a different order, basically, and proving that that can do it. But now what I see is I have this descending to 1, 0, and the plus ones are fine. The dimensions, okay, let's make the divisor equals 1, and let's do divisor. Okay, and again, I'm trying to push this towards the body of my loop I want. All right, and now divisor equals divisor times dimension 3. Okay, and then we'll use divisor. And then we'll do it again. Divisor equals divisor times dimension 2. And use divisor. Okay, so I'm using this as sort of a multiplying accumulator of those values. Okay. And then, all right. So are we to the point where we need to, okay. So I don't care about the 2, the 1, and the 0 for any reason, really. Okay, let's see if I can put this in a loop. All right, so the loop is I'm going through the dimensions backwards. And if I had each dimension as a value, I think I'm okay. Okay, so let's, that's outside the loop. All right, so if I did a loop, if I do dimensions dot, well, I got to go backwards, so I'm going to do reversed. That wasn't helpful. Xcode dot reversed. Okay. Dot for each. We'll do for each for now. Okay. Running through these things. Okay, then let's say let dimension equal $0 plus 1. Okay, because that's the value there. And result reverse dot append. Index is my input. Well, it's this. Except dimension 3, I'm calling dimension. Okay. And then I've got to set the divisor for the next iteration. Okay. So we calculate dimension, we append the value, we adjust the divisor times dimension. Okay. And how are we doing here? Then I think the next time we come in, dimension, divisor. If we calculate an extra divisor, it doesn't hurt anything. Okay, so I put it to you that this loop covers that body. Okay. Okay. Now, well, that's good. Okay. It's certainly cleaner than we started. Okay. The last thing is this appending. I don't know if there's a way to. Okay. When you're accumulating stuff across a list, I definitely tend to think there's a reduce involved. Okay. So reduce, well, I think we used it up here, right? Yeah. So reduce takes the first argument is sort of the initial value. And then the second argument is a function that, given the previous value and the current thing we're iterating over, what is the new value to accumulate to? Okay, and in our case, we're sort of accumulating two things, which is a little tricky. But I think we could make it work. I just don't know if it'll be more clear. It's nice when it works. Okay, so if I let me do a different calculation. Okay, dimensions reversed. Instead of for each, we're going to do a reduce. All right, and let's see. First argument is the initial value. Okay, and I think our values we're going to accumulate are going to be pairs of numbers. Okay, so the divisor, this is the result and the divisor. Okay, and then the second argument, well, which I don't have to write that way. I can just do this. We got to return yeah, I don't know if this is coming out any better, but let's just say result and divisor in. Okay, so this pair, empty result, divisor, we're going to calculate, we'll append the result. Okay, and then we're going to let the divisor equal, and we're going to return result divisor. Okay. Oh, I'm missing something. Result total. Well, it gives me the next item. I don't know. It's really like result divisor, comma, dimension, and then I'm going to put the +1 in here. I already know I'm not liking this better. Okay. Need a paren. No. Closure tuple parameter is not structured. Okay, let's. Cannot find result in scope. Okay. Even if I got the variables right, I don't think this is any more clear. So let's dump this. Okay. Now the result reversed. That's unfortunate, but I don't see a way around it. Because you have to know. Let's go back here. You pretty much have to know the dimensions of the earlier values before you can accumulate the leftmost ones, right? Because they're kind of it's almost based on the leftovers of this. Okay, test should pass. Yay. Okay, so we calculate indexes for index in basic array. And if I look at my content view, given the array, given the indexes, right? That's what this is. Take the array's contents count. I could probably make that more directly accessible, but get the 0 to the count of the array. That's like our 0 to 23. And then that gives you an index. We look up the value for that index, and we also now can compute the indexes for and format those into place. All right. Well, I think we have everything we need to do that. We're due for a break, though. Let's take a break, and we'll come back and get those multidimensional indexes in our text as well. And then I think that should make that look pretty good. Maybe we can figure out what's going on with this. It may be, I always wonder if it's like a, I don't know, a binding kind of thing or something where we need to make sure this can be variable. But that's okay. We'll get there. All right, so see you in about 3 minutes. Hi, welcome back. All right. So what we have, let me just write it as text. If you take array dot indexes for index 0, well, we really want to we got to calculate that inside quotes. Okay, we want to say equals and here we want to say key left parent indexes for, sorry, that doesn't need to be a quote. Okay, so the key, like A, left parent, and then the indexes for, oh golly, that and right parent equals, I don't know why this parent is red. Instant method append requires int inherit from NS object. Well, it doesn't know how to print it. I got to do a joined. Ugh. I don't know. Maybe I'm allowed to have variables now. I don't know. Let name equal, or let dimensions equal I thought I had how do I convert this into strings? I don't know. It's a lot to do in the graphic side. Let's give ourselves a new function. Let's take this out for a minute. Okay. Hopefully that puts it back to normal. Okay. Okay. Back to the old complaint. Let's add another test. Let's I want to say this is the, it's almost like a debug name. I want you to give me a name variable as a string and an index of int, and I'm going to return you the string. Whoops. How about save that for a moment. Test debug name. Well, if you say I'm going to make an array. Basic array 1, 2, 3. Type is number. Well, let's mix it up a little. String. Okay, and now if you ask me about array.debug name $, and index 8, I expect to get back $, sub 020 equals that. Okay. And we don't have a debug name. Let's add that. Just return nothing for a moment. Run this thing. Oh. Debug name. Did I not spell it correctly? Debug name. Oh. Okay. Empty string. Good. Okay. So the answer is, well, we're going to return variable. Well, let's put it in here. Return variable left parent dimension. What we can call this? Indexes right parent. Okay, let indexes equal and let's just run this one. Should be a wrong answer, but it should look better. Okay, $123 is not equal $020. Okay, good. We have to actually compute this thing. Okay, so what we're going to do is we're going to call indexes for. Okay, let indexes equal indexes for index, and then we're going to map them to strings, string of $0, okay, and then we're going to join them with separator comma. Okay, so each index turns into a little string, and we join them with commas, and that should do it. Good. Okay, so let's save that. What all have we done? Okay, add a debug name. Yeah. Okay, so added basic array.debug name to format indexes. All right, now let's use it. Okay, so we got this. Well, this we want to be array.debug name $0. Missing argument for parameter number 1. Oh, we need the key. Whoops, need 2 columns here. Because we've got 2 items in the array, or in the iteration. Okay, $1. I'd like more padding there. Actually, I'd like it more centered. Oh, not enough width. $100. I don't think something's funny. Like I'm not. It didn't. Okay. Let's put this all in one thing. Take this off. It's obviously not helping anything. Okay. $103. Okay. Ooh, something's wrong. Oh no. No, wait a minute. I reverted more than I thought. Okay, we had a frame and we had a font. Okay, so let's get the frame back in. That was on the VStack. And we shrunk it a bit. And then the font. We had an example. Here we go. I think I can just say design. So let's use default. Chinese label. Font has no member default. Oh, it's on this system. Okay. More concerning is the size is wrong, or the address is not right. Something's wrong. Okay, let's see. So if we dim a sub 1, 2, 3 equals 42. Equals 100, and a sub 1, 2, 3 is 123. Run. Okay, here's A. The formatting is not right. Something. Oh, we lost our scroll view too. Jeez. Okay, let's try that. A sub 1, 2, 3. Okay, that does not. Well, that doesn't even look right, does it? 1, 2, 3 should be. Okay, how are our numbers looking? 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3. What? Oh, I screwed up my dimension thing. Okay. Is this test still working? Okay. Oh. Oh dear. This is this 1, 0 stuff. Okay, let's go back. Let me run it. I'm dealing with the formatting at the moment. Let's make sure we're happy with that. 10 dim a sub 1, 2, 3. Okay, run it. Variables. Look at them. Let's get a bigger number. Okay, I'm not sure how you dismiss this. We'll have to work on that too. But let me run that again. Let's get one that's big enough we have to scroll. 3, 4, 5. Yeah, these numbers are not right. Okay. 3, 4, 5 should allow 0 through 5, not 0 through 6. So we got an extra +1 going somewhere. Okay, let me commit this. Add scroll view and indexes to variable display. Okay, now what's going on? It's this size thing. Oh golly. The problem is, okay, if you declare a sub 1, 2, 3, we actually store 2, 3, 4 in the basic array, which is count based. So 0, 1 is the legal range. Okay, so so I think I'm messing up my tests here then. Yeah, I think I've messed up my test. If it's a 1, 2, 3, the index should be 0, 1, 2. That's the 3 values it does. Okay, let's duplicate this page and let's make one kind of like repaired and figure it out. Okay, so this should be 0, 1, 2, 0, 1, 2, and so on. Mod 3, so 8 mod 3 is 2. 12 mod 3 is 0, 1, and then 2 should be the last value. 23 mod 3 is 27, or 3 times 7 is 21, minus that is 2. Okay. That makes this mod 3. And so this should be mod 3, mod 2, divided by 3 mod 2. And this should be 3 times 2 mod 1. Odd as that sounds. Okay. Am I buying this better? Well, let's fix these. I divided by 3. So 3 divided by 3 is 1. 1, 1. 8 divided by 3 is 2. 12 divided by 3 is 4. Mod 2 is 0. Okay, and then the last index has to be a 1. Wait a minute. 8 divided by 3 is 2. Mod, sorry, yeah, 8 divided by 3 is 2. Mod 2 is 0. Okay. And then this one, half my values should be 0 and half should be 1. I divided by 6. And that was okay. I'm puzzled. I worked this math out right. Ugh. Okay, so 0 to 3. This part is wrong. A sub 1, 2, 3 is saying the only index legal is 0. Is that true? Zero. Well, this part's coming out better. 2, 3. Okay. So in basic array, this is the count of the cells. So you want to mod by that. Okay. If there's only 6 cells, that's not really very good. Let's do 2. Make sure this all kind of hangs together. 2 times 2 times 3 is 12. Index 3, I mod 3. Yes. I divided by 3, mod 2, and this should be mod 2. Okay. That should be blue for what it's worth. Okay. 0, 1, 2, 0, 1, 2, 0, 1, 2. Okay, 0, 1, 0. And then this only goes up to 12. Okay. 0, let's take 8. I divided by 6 is 1. Mod 2 is 1. Okay. But 6, 0 through 5. This should be 11. You think it would be the maximum index at any given point, right? Okay, so 11 mod 3 is, it's not 0, it's 2. 11 divided by 3 is 11 divided by 3. Is that 3? Mod 2 is 1. Okay, that actually seems right. Oh, well, let's make sure this one. 11 divided by 6 is 1. Mod 2 is 1. Okay. Yeah, because it should be 1 less than the maximum of each of those. Okay. Now, golly. Our code's not dividing by the right things because it's adding plus 1s in there. Okay, so let's make this match our example. 0 is 0, 0, 0. 3 is 2 is 0, 0, 2. Is 0, 0, 2. 3 is 0, 1, 0. Okay. What else do we get? 8 is 102. And then 11 is 112. Okay. This should fail like crazy. Okay. Yeah. That's definitely failing. Good. Okay. Let's go back here. This index is 4. Okay. This +1 thing is not helping. Now I think we just use dimension $0, right? Our divisor is the product of the sizes, and dimension modulo the size. Okay. So that +1 messed us up. So we'll took that out. Still one messed up. Okay. Debug name. Oh, yes, absolutely. Basic array 1, 2, 3. 8. Well, 8 mod 3 is 2. Yeah. Okay, so 8 mod 3 is 2. 8 divided by 3 is 2. Mod 2 is 0. And 1 divided by 2 times 3, 8 divided by 2 times 3 is 1. Mod 1 is 0. Okay. Is that what we got? I think it is. Okay. So, yeah. So what it comes to is the array you declare, you're declaring the maximum index in BASIC. When you say a sub 10, you're saying the maximum index is 10, but you're also saying the initial index is defaults to 0. Well, there's no defaults. It is 0 because it's always 0. And so there are 11 values. And when you call basic array, you're saying you're an array with 11 values in that column. And, so we got to translate. All right. So let's say fix indexes 4 to account for dimensions being the count, not the maximum. And it's like, go work out all that math, and then like, oh, whoops. Okay, let's run this. Okay, so dim a sub, let's say 1, 2, 3. A sub 1, 2, 3 should be legal. A sub 0, 2, 2 should be legal. Okay. Whoops. That's the old output. We didn't accumulate. Now, this is all great, but did it run? And also, okay, we got to worry about dismissing. Let's dismiss array display. I think you're supposed to be able to, like, I don't know, is it a 2-tap? There's some way you're supposed to be able to do it, but okay. Okay, apparently it didn't put it anywhere. That's really disappointing. Okay. Let me run that again. Let's just do a one-dimensional one for now and make sure that's, oops, line 10. A sub 0 equals 10, a sub 10 equals 110. Run that. Variables. Okay, that looks good. Doesn't look great, but it's correct. Um, yeah, I'm pretty sure you're supposed to be able to do a click draggy kind of thing or just tap the background. We'll have to look at that. Okay. That seems fine though. So let's run it again. All right. Dim a sub 3 comma 4, a sub 0 0 equals 100. A sub 3 comma 4 equals 34, 134. A sub 1 2 equals 112. We got 0 0 3 4 1 2. 0 0 1 2 3 4. Okay. Well, that seems okay. Try 3D again. I'm messing up something here. 10 dim a 235. A sub 0 0 0 equals 1000. A sub 235 equals 1235. A sub 132 equals 1132. 0 0 0 235 and 132. 0 0 0 132 235. Okay, I must have been looking at something wrong, I guess. Okay. But I think we have that done correctly now. Let's see, do we have any files checked down? To do. Okay, good. Alrighty. With a display. Hi. All right. The display variable view. And this is too much. But okay. Show array contents equals true. Let's find the sheet. No, oh, maybe this is the one. I know I read an article yesterday and I thought they said it would close it automatically. Okay, so we're doing the similar thing. Show sheet and the button click changes it. Okay. Dismissing. There are 3 ways. It requires no effort. Drag it towards the bottom and the sheet will go away. drag, drag, drag. Okay. Notice it said provided by iOS. This is Mac OS, so I think maybe there's just a difference. The other way is put a button on the sheet. Basically a dismiss button. Yeah, I think let's try that. To close. That really sounds complicated. Okay, yeah, let's not do that one. What was the second one again? The second method is convenient when we implement a sheet in its content closure. We simply change show sheet. There's a button along with the text. Tap on it and it becomes false. Yeah, that's what we want. We'll put it up here, I guess. Okay. Right. So present the sheet. Where's show array contents? Up here. Good. Okay, so we have access to it. All right. I think this information can go away. All right. So here we'll do an H stack. The tab. Well, let's put the spacer. Text, a spacer, and a button. And on click show array contents equals false. There may be a better way to do this. Oh, like one thing would be balance your braces. Nope, I don't have any variables to look at. Okay. Tandem A sub 10. Run variable A. That's all right. Yeah, okay. Well, sorry. Let's mark that on our to-do variable display. I think we did that. Whoops. Dismiss array display. Okay, yes, that's what we've been doing. One more look here. Excuse me. Yeah. Okay. The look's a little ugly, but I don't think it's unbearable. I didn't know if making it text. Let's just try it. Text dot on tap. I guess I like that slightly better. We'll commit. Okay. Add dismiss button to variable to array display. Okay. Where's tapped A coming from? Fine. Tapped A. Ignoring case. Somebody did that. I know I had that code somewhere. Probably in this file. Yeah, okay. We don't need that. Okay. Sorry. Let's run this. Run variables. We can dismiss it, and I don't know if we can run again. Yeah. Okay. We've got some work to do there. All right. The only thing that's still bugging me is this little non-constant range. Let's see if we can figure out from documentation what's supposed to happen there. How I do that. Okay, so this is SwiftUI containers based on a random access collection. That's probably the problem. I'm not really a random access collection. Named font corresponds to identifiable. Yeah, this is the other thing. Okay, so the setup on these is that they want to be independent lines because you might rearrange them. And if you want to efficiently show it, if each one has its own ID, you can kind of match up the IDs and do a diff, and it's like, okay, yeah, I can see where the differences are. But if you've got the possibility of duplications within the list, 3 lines that look the same, how do you know which one you're really overwriting or replacing, right? So you don't. And that's why they want identifiable or hashable and all that. That identifiable is the nicest because then it can just figure out which one goes where. Init. Now this one's the one we're using. It says over a constant range. That's okay. So that's where we're getting our complaint. Okay. If we want to do data, instance that uniquely identifies views based on the identifying underlying data. Oh, now we wanted to show values. Maybe it's not so bad. I mean, if you wanted to show, let's see, our variables, right? Each of these lines is different because they're always going to be based on the indexes, and if the indexes change, if a value changes at an index, that line will clearly change. If we had A7 equals 42 and we redisplayed it with that, it would know that A sub 6 and A through 8 through 10 are the same. And it would say, I used to have an A7 equals 0, and now I have an A7 equals 42. Those are different. Let's replace it. So these strings are actually suitable for this. Now, how we get the list, that's trickier. I mean, I guess we could push this all into our array like we did debug name. We could make a structure that holds all of the variables. We kind of do that, I think, right? And we copy something in REPL. Yeah, we pull store and we mark that as a published thing. Now, is a hashable a random access collection? I don't know, but um, it's hard to know. Okay, so we're we're capturing store here. The reason we capture it is we want our content view to be able to display it. Okay, and up here, and this is really, yeah, right. We're filtering. Let's see. What are we looking at? The REPL.store. Yeah, so we're iterating over REPL.store, sorted and filtered and processed. I think. Yeah, I mean, almost this could be done at the REPL instead of just capturing the store. I think we could capture these are the displayable things. Now, how do we capture that array stuff? That's a little different. Yeah, non-constant range. It really is. That really is problematic. Based on what we saw in the if you reach here where it says it's got to be a constant range. Available data is range event. It isn't. Well, that's good. The id is the unique number, but that's identity of underlying data. Rotor content. I don't know what rotor content is. It's not helping me much. Okay. I don't. I'm not going about that. Okay. Well, what I learned so far, I mean, I definitely could pull this into the REPL, right? Because this, I think it's in effect, it's $1 is function sorted by key, ID key. Okay, yeah, we could just turn it into a list of strings. Yeah. it's hard for me to know when. I mean, right now, store is, let's see, on REPL, store is a published field. So if anything changes in the store, that screen gets notified. The nice thing is I don't do all this stuff. I mean, I don't know if it matters, but I'm not doing these things until I actually display this screen, in which case I get the stuff out and see it. But, okay. We had ordered dictionary. The problem was it's the order it uses is the entry order. Well, is there a sorted dictionary? Sorted dictionary. Yeah. Okay. It doesn't. Okay. People have defined them. Yeah. This is kind of the wish list. Right. Yeah. So, okay. Different people have implemented them. It should be in the algorithms library. Yes. Let's try that. Swift algorithms library. I think we looked and didn't see this the other day. Sorting. I guess we'll look at this. Is there a sorted? No. Okay, no, that's not useful. All right. Yeah, it would be nice if my dictionary could be a sorted dictionary. I've debated about whether I should program it instead of being a map, could be a list of strings. Maybe that would be better. I don't know. I mean, it's pretty short now. Okay. Boy, getting a little lost here, aren't I? So this stuff. All right. If you had an array, let's pursue this a little bit. Let's put this stuff in an array on demand. If you ask for array dot value, maybe it's arrays dot debug contents. Okay. Let's introduce that. Okay, so. Oh, excuse me. Hi, you got a brown rabbit. That's cool. Can you take it over to Henry? Sorry. All right. So let's do func test. Debug contents. Okay, so we'll make an array. Array of let's just make it 2. Yeah, I think we can get by with this. All right. 2 and type is number. And if you say array.debug contents, call it A, then we should get back A sub 0 equals 0. Should be a collection, so let's put these in strings, in an array better. And A sub 1 equals 0. Okay. I guess this is my output expected. There, is that better? All right, so if you say array.debug contents for the name of the array, then I'm going to list out all those values for you. Okay. There is no method debug contents. And it returns array of string. Okay. Empty string for now, and test. Certainly should fail. Okay. All right, empty string, empty array is not equal to A0 equals 0 equal. Okay, now we had that in content view. It's like this. Well, let's take the whole thing. Just for reference. Okay, so array dot contents. Do we need the content values? Well, it's really this, isn't it? 0 dot dot that. Array contents. Count dot for each. No, it's not for each, it's map. Okay, so we're going to run through the content count, 0 to whatever, that's the index. Okay, and then we're going to return this. In here, it's just contents, okay? Isn't it? Yes. Okay, so don't need that. Okay, map each content to, well, that's kind of this, isn't it? Debug name for variable with index. Let's be explicit here. Help ourselves a little bit on the readability. Index array get index dot format. No array, just get. Okay, so we're going to map each line each index in the array to debugs a variable index equals get whatever. All right, let's run that. Well, a sub 0 equals 0 equals 1 is not equal to a sub. Quote a sub 0 equals 0. Oh, spaces, yeah. We do put spaces in. Okay, and let's try that in our content view. So we want to do, whoops, for each array dot debug contents for key, isn't it? Yep, key. ID. Oh, I threw away a piece of paper. /self. $0. Okay, for each thing, the debug contents identified by itself. Since they're all unique strings, there's no issue there. And run. Okay. One, two, three, and 2, 3, 4. One, two, three equals 1, 2, 3, and 2, 3, 4. Okay, good. All right, so let's commit this. Edit debug contents to basic array. Use that in variable display. Now, why? I was gonna say, why is it happy with this and unhappy with the iterator we had with the count? I don't know exactly. I mean, I guess there's more work if it had to keep track of the counts and decide if there was the same count and all that. Maybe, I don't know why they made that restriction when they're perfectly willing to show this array that I just made up on the fly, right? Yeah, I don't know, but I'll take it. Okay. Whew. Okay, where's our to-do? Handle parser error. Remove location from array methods. Okay, so from the UI end of this, let me just do one more little trick here. If I put a couple of spaces there. Probably one space would suffice. Just got to get past that rounded corner. think that's good. Okay. Um, good. Okay. This, let's see, that question was location from array methods. Oh, yeah. Okay. The issue is we need to throw an exception in some cases. If you access values out of bounds, we definitely want to throw an exception. If you try and so if you try and get something in the variables out of bounds, then we need the location. I want to change that. I want to make it the caller's problem. Okay, so let's get rid of it here. Okay, and I think I don't know, I think you can just make an error. Maybe you have to have a default. Can I make a generic error? No, not generics. Okay, Hacking with Swift, great site. Okay. Do contents equals try data. How to throw. Before you throw, you must make a list of errors you want to throw. Okay, the deal is I don't want to tell it where the error is because I don't want to know at this level. It's not really my problem. Before, this code existed in the interpreter, and the interpreter knows the location at that point. Okay, if I throw it away, I don't know, interpreter error is not really the best error, is it? That's public enum. Array error. Extends error. And we're going to make out of bounds. Out of bounds. Okay. Oh, no. Case. Sorry. Okay. So I want to throw an array error dot array error dot out of bounds. Okay. And so I'm not going to pass location. Okay. Now, what's going to happen? Hopefully a test fails. Let's make sure that's true. Good. Okay. Error message includes line number. Okay, well that's fine. Array access out of bounds. Okay. Yes. All right. So now my gets and puts that have locations, I've got to allow the possibility that they throw, but I don't want this location because I'm not going to use it. All right. So let's take this out. We should get some complaints. Extra argument. Yeah. Okay. So array, what is this? Fetch array value. Okay. So what we need to do is we need to catch it. We don't want this location in here. Okay. And then if we catch our type, right, throw, oh yeah, this kind of thing we'll catch, and we have to have an extra catch. Catch array error dot out of bounds. Okay, well, then we need to make an interpreter error out of it. Dot error location dot line number, and let's see what we had originally up here. Array access out of bounds. Okay. And if we don't see that, well, this is really, it shouldn't happen. Interpreter error dot can't happen. Okay. It makes more work on this side. But I think that's how we want to do it. We want array to own the array job, not own locations or any of that stuff. Okay. Let's see. Build. Run tests. Now we should get errors on the put tests. Okay. Yeah, so these are putting stuff on the wrong out of bounds, and unexpected error out of bounds. All right. Oh, we got the error out of bounds because the array error just leaked out. Nobody caught it, and that's fine. I mean, it gets caught at the top level where it looks for exceptions. But we would really like to wrap that so that it has the line number and stuff in it. Okay, so let's back to basic array. Put with the location. Well, index 4 doesn't need the location, so let's make this not need the location. Somebody should complain on the build. Okay, so case array access. So again, we want to put this in a do catch. Array error dot out of bounds. Okay, and what's this default? Oh, okay, yeah. Array error out of bounds. Well, I think we want that same message. Somewhere fetch array. Okay. If we do this and we catch array error out of bounds, oh, maybe our can't happen doesn't need to be there, since it will just leak out whatever it is. Yeah. Okay. This should pass now. All right, and then let's find that fetch again. Okay, I believe I can leave this off. Since I say I throw, if anything else throws from this, it doesn't get intercepted, but this method says it throws. So it will just pass that exception along. And we don't believe there's normally, well, that's the only throw we have, so it's okay. It was a can't happen before because it really shouldn't be able to happen. But if we introduced another error that we could throw and we didn't account for it, that'd be interesting anyway. Okay, so remove location from being passed into basic array. Let basic array throw its own exception, and the interpreter catch and handle it. A little technical, but that's okay. All right, so that's really a refactor. All right, I think that'll keep us straight there. Okay. Rebel should scroll to bottom. I wish I knew why that didn't work. Okay, I'm just looking down. What's next? All right, input. Data read restore. Okay. We noticed something else today. Running can't run interpreter twice. Okay, that's worth looking at some point. Sync by skipping forward. Okay, parser errors better. I'd be curious what's up there. I thought we did have line and column number. You know, we certainly could show make errors show failure point. Okay, so what I'm imagining there is 10 dim a sub 2 3. Well, I think what we'll show will be the squeezed version, which is what gets looked at, and something like this. Give or take, the caret might be on the 3, or I don't know exactly where it's going to be, but somewhere indicative, like, hey, there's something wrong here, and what do you want to do about it? And the fact of the squeezed version is what really gets parsed, because early on we squeeze out any spaces that aren't in quotes, and we uppercase it. Dim. This is what actually gets parsed. Harder to read. Ideally, I would like to show it on this version. The actual line would look substantially better. Another thing is I don't know. The uppercasing, it almost should be done anyway, because the spacing and uppercasing, I don't know. It'd be nice to automatically format these lines, because if you notice when I was typing, I was kind of sloppy about case and stuff like that. but this would be a step forward, and eventually showing it on the actual line and not needing to show the separate line would be progress too. Okay, error sync. What should ASCII do if given an empty string? I think we'll make an answer up for that. Parameterized test package. I almost want to. I think. Well, we're getting close to the end. I think if we handled these extra statements and some of these other little kind of quality of life things, they would that would wrap up the interpreter part of this project. I want to do a compiler out of it, or at least the basics of that, and that's the second project. I want to refactor to a compiler or the start of a compiler, and I also want to work on this parameterized test package. I put it together. John Reed used it a little, gave me some good feedback, and I know I have ideas on a package like that could show up in here. We've got a lot of tests. There's a lot of duplication. I guess, let me see if I can find interpreter tests. Yeah. We extracted out helper methods, but you could imagine this being even simpler. I don't know. And some of these are kind of working their way through combinations of stuff that can go wrong. It's hard to know. Yeah, maybe the parser is a better place to look for examples, but we have expressions of various sorts, and it would be nice to go through and kind of figure out these complicated expressions and make sure they're working right. I don't know. We'll see. But I think in general, there's room for parameterized testing, which we're kind of doing with this check print. Like, yeah, this one would be look better to me as a just more test cases and that sort of thing. I don't know. We'll see. But anyway, I'd like to build up that parser parameterized test package, and I don't think it's 50 episodes or anything, but I think maybe a week or two of work could get me maybe some combinations testing, or well, I have the notion of parameterized testing. I also would like to be able to do combinations testing where I feed in ranges of stuff and it builds expressions, and that's fine. And then I'd also like to explore some more generation kind of stuff. I don't know. We'll see. I don't think I want to go full blown property testing kind of thing with automatic generation, but I'd like to be able to support property tests. I don't know. There's room for experiments there. Xcode test, it's a little old school at this point, a little long in the tooth on some things. This is a chance for me to explore some other stuff in the testing world, and maybe there'd be some interesting things out of that. We definitely have, like, this should always make a well-formed tree. Well, that'd be a nice property test. Okay. But anyway, I think we've done well today. We got through most of the problems on this variable display, the debug contents and so on, moving stuff into the right classes and cleaning up, I think, was a good thing. We'll do next time, I think we'll do this input statement. We've been running that little maze for a manual test, and it's got one line that can't be handled by our current interpreter, and it's an input statement. So I have a small incentive there. All right. Thanks for joining me. Next time will be tomorrow, which is Friday at 10 a.m. Eastern Time to 12:30 p.m. or 3 to 5:30 p.m. UTC, or if you're in Central or like me, for me it's 9 a.m., but 10 a.m. Eastern, you can work it out from there. All right. Have a good evening and take care. Bye-bye.